In this section, we are going to learn everything about sonar sensor and try to make a distance meter using this sensor. Okay. Now, first question is, what is sonar sensor? Basically, sonar sensor is a special type of sensor that can measure the distance between its own position to an obstacle. Simple. It always uh, ultrasound ultrasound to measure the distance. That's why this sensor is also called as ultrasonic sensor. Ultrasonic sensor. Okay. So before we go any further, let me tell on things. Sonar sensor is the most important sensor in Arduino sensor family. So please don't skip any part of this video, guys. This video going to be very informative. Okay. So this is the physical overview of a sonar sensor or an ultrasonic sensor. At a first sight, it may seems to you guys that a pair of eye is looking at you, but it's not. It is basically a transmitter and receiver in this module. This is T, means this terminal is transmitter terminal, and this is the receiver terminal, and this terminal always transmit the ultrasonic sound. Okay, ultrasonic sound. And when the sound interpreted by any obstacle and return to its uh, own, then the receiver terminal receive that signal like an echo. Okay, so it has four pins. Two of them use for power, which is VCC and ground. We always use plus 5 volt from our Arduino, and this ground to ground. Okay, and two of them we can use these pins for controlling the total module and calculate the distance. But obviously it cannot be used as a standalone device. Rather than, you need, of course, a microcontroller to use this sensor and measure the distance. Okay. Now let me clear another things. uh, Suppose uh, without any sensor, how you can measure a distance through sound. Suppose you just stand over here, and here is an obstacle over here. Now suppose you create a sound. Okay, you create a sound, and your sound goes all over the space and hit back by the obstacle and return back to your here, right? And you can calculate, or you can measure the time between the your transmission and reception the sound. It is possible, right? We know that. Suppose the time interval is t second, and you know the velocity of sound is on sorry, 342 meter per second, right? So what does it means? It means in 1 second sound travels 342 meter. And if we want to convert a smaller unit, then you can say in 10 to the power 6 microsecond sound travels 34200 centimeter. Okay, so for 1 microsecond sound travels 34200 divided by 10 to the power 6 centimeter, or you can call it the 0.0342 centimeter, right? Okay, now for example, you can consider as the time is suppose 30 microsecond, which is the duration time between the transmission and reception the sound. So the total distance will be, we know that distance equal, we know distance equal velocity into time, velocity into time, right? So s equal v into t, right? Okay, it is centimeter per microsecond, obvious. So just if we just multiply into 30 into 0.0342, it return to you a value, but this is not a actual value. Why? Because this value is included the going and return value, right? Because when we know that distance from you and this obstacle, right, and the time, the traveling time is included not only the going time but also the return time, right? So if we just divided by 2 in this total value, then we get the proper or actual distance, and by using this formula we can calculate the distance using the ultrasonic sound and the Arduino. And a very good advantage over here, when the reflected sound or echo return back to this receiver, the echo pin goes high. Okay, so when we connect the this sensor to an Arduino, first of all connect VCC to 5 volt, E ground to ground, and trigger pin at defined as an output pin. Why? Because Arduino create a signal through this pin and create a trigger sound of ultrasound or ultrasonic from the ultrasonic sensor, and when it return back to the receiver section, it calls an echo. So echo pin is defined as an input. And why input? Because when the sound on the return sound or the echo sound came back to the receiver, the echo pin goes high, and when and Arduino always just focus on the echo pin when the echo pin goes high, just it Arduino calculate the total distance between the making it trigger and receive the signal or the high signal from the echo, and calculate the distance of t, that will be the microsecond unit, because we calculate the short distance, right? Under the 400 centimeter is the maximum distance measurement range of this module. Okay, so of course the frequent the time will be in short microsecond unit, and when we just calculate the distance, then just multiply the sound that we have calculated, already calculated in the Arduino, and the constant value, which is 0.034, and make, and then divided by 2, we get the proper result. So in the algorithm of this code, let me write an algorithm. First of all, define the trigger pin as output and the echo pin as input. Okay, then first of all just normalize the trigger pin, and delay some small amount of time, then create a pulse. Okay, create a pulse for approx 10 microsecond, then take a variable of duration, duration, and duration will be the how much time the echo pin goes high. So you can use the pulse in function to read the echo pin, right? Echo high, that means it gives you the duration until the echo pin goes high. Okay, so you get the proper duration. Then for isn't the distance, just you just multiply this duration into 0.034 and divided by 2, and you get the proper distant value. Okay, so now let's assemble a simple circuit diagram, and then we just assemble the code following through this algorithm. And okay, this will be our simple distance meter under 400 centimeter. Okay, to make the distance meter, we need just a breadboard, a sonar sensor, and Arduino of course, and some jumper wires. So first of all, take a jumper wire and connect the positive rail of the breadboard to the 5 volt of the Arduino, and negative rail of the breadboard goes to the ground pin of the Arduino. Okay, now insert your sonar sensor to the breadboard. So first of all, this is the VCC or 5 volt pin, then trigger, echo and ground. So I just insert the sensor to the breadboard, and this is the ground pin, the left side. Then I connect the ground pin of the sensor to the ground rail of the breadboard, and the positive side of the sensor to the 5 volt of the breadboard. Then it's the echo pin. This is the echo pin just after the VCC pin. I connect this pin to the pin number 3. You can use any pin. Okay, and trigger pin, I connect the digital pin number 2. You can use any pin of course. So this is the simple circuit diagram to make a distance meter. Just connect the positive rail to the 5 volt power source, or VCC to the connect to the 5 volt, ground to the ground, trigger pin goes to the pin number 2, and echo pin goes to 3 pin number 3, digital pin number 3. So this is the full circuit diagram. Now write some code and upload in the Arduino and see some action. Okay, as per our circuit connection, we define two variables, like trigger pin goes to 3 and echo pin goes to trigger pin goes to 2 and echo pin goes to 3. Okay, now in the setup section, we define different pin mode, trigger pin as output, and output, and uh, echo pin as input. Okay, then use the serial begin because we want to use serial monitor to see the result. Then in the loop section, first of all, normalize the trigger pin, just digital write trigger pin as low and delay microsecond to small amount of delay. Then create a pulse, just write digital write trigger pin high, and for small amount of time like 10 microseconds. Then digital write trigger pin as a low. Okay, and low. Okay, so create a pulse, then receive the signal, receive the echo. So here if the double duration equal, just we use pulse in function and pass two parameters. First of all echo pin, and until the echo pin goes high it takes the time, and finally it back to the duration variables. Then calculate the distance, let the distance, here distance is just multiply duration into 0.034 and divided by 2, the final result. So serial print, we use distance and then serial print, serial dot print, just print centimeter. Okay, and delay sometime like 50 millisecond. Okay, that's all. We done a complete code for uh, making a distance meter, short distance meter. Now connect uh, the Arduino to your laptop or computer, then hit the upload button. Okay, first of all we need to select the board and port, then hit the enter. Okay, our programming done successfully. Then open a serial monitor over here, just hit the serial monitor button, and okay, you can see the distance between the sensor and my earphone. It's so 8 9 10 centimeter, 12.04 centimeter, it's 4.78 centimeter, like that. So okay, our distance meter working perfectly. It is the fundamental application of this sensor. By following this step you can use any project related to the distance measurement project. You can use the sonar sensor perfectly. This is the proper way to coding, and I also discussed about the working principle of this sonar sensor. Okay, now let me just add it on things. Let's modify this circuit a little bit. Basically we want to add a LED, and our target is when obstacle come within 5 centimeter the LED will turn on, otherwise it remains off. Okay, so I connect the LED like its previous, connect the ground pin to the ground rail, and positive side we added 220 ohm resistor, and other pin goes to any digital pin of the Arduino. Here I want to connect pin number 4. Okay, that's it. Now let's modify the code a little bit. Okay, just define another variable called LED, and since we add this LED to the pin number 4, that's why we write int LED equal to 4, and in the setup section we define the LED as output, and in the loop section we just write an statement or condition: if distance less than 5, then LED turns on. That's why write digital write LED high, and otherwise it keeps off. LED low. Okay, then hit the upload button first. But before of that, select the board and port, connected the. Okay, then select the board and port and hit the upload button. Okay, now as you can see, when the obstacle come within the 5 centimeter, then LED will turn on and is turn off, turn on and turn off. Okay, you can also buzzer instead of this LED, then your circuit just generates some sound when the obstacle come within a certain range. Okay, so it is the application of the sonar sensor. You can use this sensor any project where you need the distance measurement. So that's it, and go ahead for another topic, another module or another sensor.